Welcome, my dear friends. So here we are with second part of the chapter factorization of algebraic expressions. So in part 1 we have learned about what is factorizations, and type 1 we have learned that taking some common we can factorize a given algebraic expression. Now here there is another type, that is, I've just marked it type 4, but it is actually perfect trinomial squares. Now let us first get familiar with this expression sentence that is called perfect trinomial squares. What does this mean? Now trinomial, you know, it is 3. Okay, trinomial means 3 terms. Perfect square, like we say 36. 36 is a perfect square. Perfect square. Why? Because we know to get 36 we need to multiply 6 2 times. A same number when you multiply 2 times and the product is called a perfect square. Similarly, in an algebraic expression also we have perfect squares. So like this. So perfect trinomial squares. Now this one, here we have 3 terms, a square plus twice ab plus b square. You know that a plus b whole square. Now a plus b whole square is a perfect square. Okay, perfect square. Why? Because a plus b into a plus b will give you this expression. So this expression is called perfect trinomial squares. Now in short, we will try to remember a perfect trinomial square in this way. Okay, in this way we will try to understand any number, squares of any number. Okay, I have marked this here. This a I have marked as first number, and b I have marked as second number. Now first number is square, then plus second number is square, plus, it can be plus or minus. Okay, so let's say for example I have taken plus. So plus, so this middle term you have to get by multiplying 2 with this first number and second number. Then that expression will be called as perfect trinomial squares. We'll come we'll see with an example. Now we can so what is perfect trinomial squares? If we can express in this format, or you can simply mark this format as a square plus, or it can be minus twice ab plus b square. If you can express a 3-term algebraic expression in this pattern, then that will be called as perfect trinomial squares. Okay, let us learn with an example. Identify the perfect trinomial squares. Okay, let us now say, let's say this is an algebraic expression having 3 terms. Now is it a perfect trinomial square or not? Listen here, to be a perfect trinomial squares we have to satisfy these conditions, that is a square, it can be plus or minus twice ab plus b square. It means whatever value of a and whatever value of b you get, that you have to multiply by 2 to get the middle term. Okay, let us see here. And remember, this b square and a square and b square are always positive term. Okay, in perfect trinomial squares, a squares and b squares term, both these term are positive term, and middle one twice ab, it can be positive or it can be negative. Clear? Let us see here. Now this is b square plus 14b minus 49. First let us try to express in a square. Since there is plus, let me take it plus twice ab plus b square. Okay, clearly this is not a perfect trinomial squares. Simply you can see here b square term is positive, but here it is negative. It cannot be negative as I have marked here. Then also let us see if we can find a square and b square. Now to get a square means first term. Okay, simply remember first term, that is b square. You know, if you multiply b 2 times you will get b square. That means b whole square will give b square. And to get 49 you need 7. If you multiply 7 2 times then you get 49. So we have the first term and we have the second term, and middle term, you know, you have to multiply 2 with this first term and the second term. Okay, so 2 into first term is b, So 2 into b, and second term is 7 into 7. Now this middle term, if you write in this way, whatever middle term you're getting here, that is matching with the given question. That means everything's okay except this minus. Okay, it should be plus. If it were to be plus, then this will be a perfect trinomial squares. Okay, so which is not equal in this format? A square, there is a square, there is b square, there is twice ab also matching, but this is not matching. Here it is should be plus, but here it is given minus. Okay, for that reason this expression is not perfect trinomial squares. Let us come to another example. So a square plus 10a plus 16b. So let us see this will be a perfect trinomial squares or not. Now we have to, since there is plus, I will take a square plus twice ab plus b square. In this format I have to check. Now first term square, that is positive, okay, and the second term square is positive here, and here also it will be positive. Now this will be the middle term, twice ab form. Let us see everything is matching or not. First let us find the two squares which take the place of a and which will take the place of b. To get a place first term, so a square, that means a, if you multiply 2 times you are getting a square, so a whole square. And 16, you know 16 means 4, if you multiply 2 times you are going to get 16, so we can write 4 square. Okay, if you put here 4 and do square, then you will get 16. So now we have first term a, the a itself, second term b, that is 4. Now middle term. So middle term, you know it should be 2 multiplied by first and second term. So here first term is inside bracket is the first term, don't take this square. A is the first term and here 4 is the second term. So 2 into first term into second term. Okay, now we have 2 into a into 4, it gives 8a, but we have here 10 square which is not matching with the given expression. That means this is also not a perfect trinomial squares. Why? Because the middle term is not in the form twice ab. Clear? Now come to another example. So 14m square plus 140mn plus 100n square. This will be a perfect trinomial squares or not? Let us find it. You know 49. Let us first see the squares of this 49. Means what will be the square of a number that will give 49? So it is 7. 7 square gives 49. Now m square will give m square. So 7m will be the first term. Now let us check the second term. Okay, middle term will come later. 100, you know 10 into 10 gives 100. That means 10 square will give 100n. N square will give n square. So 10n whole square. Now we have first term as 7m and second term which we are defining in our expression as b, it is 10, and now middle one you have to get by multiplying 2 into these two terms, first term and second term. So 2 into first term, see 2 into first term and 2 into second term. So if multiply you will get 140. Now if you exactly see the given expression, it is matching with respect to sign as well as the each term, it is matching. That means this is in the format twice a square plus twice ab plus b square. That means this expression is a perfect trinomial squares. So in this video we will try to factorize this type of expression which is a perfect trinomial squares, and which are not perfect trinomial squares we'll discuss in the next video. Okay, now what we have to keep note means we have to keep in our mind while we are choosing or finding perfect trinomial squares. First, the two square numbers you have to find. Okay, like here this 7m and 10n. So these are the two square numbers we have to find. Okay, then second point you have to keep in mind that second, multiply the two squares number by 2. Let we have checked here, this we have multiplied the two squares number with 2 and we are comparing with the middle term with the given expression. It is matching or not. Okay, if it is matching, that is okay. Now after it is matching, now we know that there are two perfect trinomial squares we are discussing. What is a plus b whole square, another one is a minus b whole square. Now it will be a plus b whole square or a minus b whole square. If it is minus middle term, I am talking about middle term, if it is minus then it will be a minus b whole square, and if middle term is positive then it is a plus b whole square. That means this we can write in the form a plus b whole square, because middle term is a means what? First term 7m plus b means second term, that is 10n whole square. So in this way we can write. Okay, now we come to the factorization part. Factorizing the perfect trinomial squares. Now this is a questions, okay, which I'll solve for you, that is I'll factorize it for you. Okay, since three term, let us check first it is perfect trinomial squares or not. Now see, this is itself a whole square number, square number, and this is 1 itself is a square number. We know a square will give a square and 1 square will give 1 square. Now middle term you have to measure, that is 2 into first term into second term. That means this is the first term a, this is the second term 1, which is, so if you multiply you are going and getting back the given expression. That means this is a perfect trinomial square, which is in the form, since middle term is positive, so plus. So we can write a plus b whole square. Since a is the first term and 1 is the second term, so a plus 1 whole square, which if you factorize you can write in this way. Next, another one. Here you have 16a square minus 40ab plus 25b square. Now, so this can be our first square number and this can be our second square number. Both positive, it is well fine. Now, we know 16 you can get by 4 square. If you do 4 square, you are going to get 16. A square you can get by a. So 14a whole square will give 16a square. Similarly, to get 25, you need to do square of 5. And to get b square, we need to do square of b. So 5b gives 25b square. That means we have now first term. This is the first term bracket part, and inside this bracket is the second term. So middle one, you know, it will be multiply of this first term and second term by 2. So 2 into first term and to second term. If you multiply and check, which gives 40ab, which is matching with our given expression. That means this is a perfect trinomial squares. Now it will be a plus b whole square or a minus b whole square. As I have explained, see the middle term, it is negative, so it will be a minus b whole square, a minus b whole square. So as we have already said, 4 is the first term, 5 is the second term, so first term and a second term whole square. So this is already factorized. Let us see another one. Here, so this can be expressed as a square number, and this is also can be expressed as square number. And if we are able to change the middle term in the form twice ab, then this will be a perfect trinomial squares. Let us check. Now x square to get, we need x. Squaring will give x square. 4 we need 2, because squaring of 2 will give 4, and y square we need y. So x by twice y, if you do whole square, we are going to get this first square number. Second square number will be this. Let us check it is matching or not. 4y square 9x square. So 2y and twice x, if you do whole square, you will get this term. Now middle term, as you know, 2 you have to multiply this first term and second term. I have just calculated here in rough. So let me see, I will get 2 by 3 or not. So this is 2 into first term into second term. So first term I wrote here, second term. So after calculating, we are getting 2 by 3. That means it is matching with the given middle term. That means this given expression, algebraic expression, is an perfect trinomial square. So now, since middle term is negative, so it will be minus a minus b whole square. That is, m is first term. This is the first term and this is the second term whole square. So now this is factorized. Okay. Next, as we have learned how to factorize, now sometimes we have questions like this. Find a square root of the following trinomials. How we can find a square root of trinomials? You know, if you want to find a square root of 49, it is very easy. 7 if you multiply 2 times, we are going to get 49. That means square root of 49 is 7. Similarly, what we'll do, since we need to find the square root of this trinomial expression, first we check if it is perfect trinomial squares or not. Why? Because we can write whole square. If you cannot whole square, then we can easily take the root over. Now this one can be expressed as a by b whole square, and this will be the second square number, which can be expressed as b by a whole square. Now if you multiply 2 with this first square number and the second square number, if you are going to get a cancel, b cancel, so 2. That means it is matching with our given expressions middle term. That means this is a perfect trinomial squares. Now we can write whole square, a plus b whole square. Now here a means a by b. and b means b by a, so whole square. Now to get root over, just put plus minus root over this value, put, you know, this square root will be cancelled by 2, then we have this, which is the square root of the following expression. Now why I have put here, now see, normally when you are writing root over 49, we are not taking plus minus. Why it is plus? Now see, plus minus necessary in some particular case, okay, so better we put plus minus now. Now why plus minus? You know, the positive 7 square also 49, minus 7 square also 49. That means for 49 we have two number, which if you multiply 2 times, then you are going to get 49. That means in every square number has positive number and negative number. Normally we are dealing with positive number because whatever questions we are dealing, it requires positive number, not the negative number. That's why we are normally neglecting the negative numbers. Okay, thank you. Enjoy it.